Okay, here are quiz 5 solutions. We're asked to find the derivatives for a bunch of different functions. So we want to find f prime of x here. And the way we'll do that is we'll take the derivative of this huge mess that we're given. 2 times 2x to the 5th plus 3x plus 5 raised up to the 5th power. The first thing I want you to notice is we got a constant out in front of this whole thing. So I could just figure out 2 times the derivative of 2x to the 5th plus 3x plus 5 to the 5th power. You don't have to do it this way, but I think it makes it a little bit easier. There's less to look at over here. So what's that derivative equal to? Well, in order to find out what this derivative is equal to, you're going to have to use the chain rule. The inside function is this polynomial. The outside function is x to the 5th power. So using the power rule, I take this 5 right here and I bring it down in front. And then I subtract 1 from the exponent to get a 4 here. And what do I have here? Instead of an x, I have this polynomial, 2x to the 5th power plus 3x plus 5. You might think you're done here, but you're not, because this power rule applies when you have an x here. We don't have an x here, we have this polynomial, so my chain rule says I still have to multiply that by the derivative of 2x to the 5th plus 3x plus 5. So finally, if I recopy everything that I have above, all I have to do is figure out this derivative here. And that's not too bad. The derivative of a polynomial, we can just look at it term by term. The derivative of 2x to the 5th is 10x to the 4th. The derivative of 3x is just 3. And the derivative of 5 is 0. So you get something like this. I don't know, you might take the 2 and the 5 and multiply them together. You don't have to, I don't care. I did say you don't have to simplify your answers. So either one is totally fine. We'll call either of these good for our final answer to part A. Part B, same basic idea, find the derivative. Well, let's see, it looks like I got functions inside functions again. So to figure out g prime of x, I have to take the derivative of this mess that I'm given, x squared times e to the 2x plus 1 to the 3rd power. Well, to take that derivative, I again recognize that I have a function raised up to the 3rd power. So my outermost function is x cubed. So what I can do is I can kind of apply the power rule and take this 3 down in front, leave all this mess on the inside that's kind of playing the role as the x in the power rule, and then subtract 1 from the exponent. Unfortunately, at this stage, I am not done, because I still have to multiply that times the derivative of x squared e to the 2x plus 1. What is the derivative of x squared e to the 2x plus 1? I'm going to have to use the product rule. It's something times something. The f in my product rule is x squared. The g is e to the 2x plus 1. F prime, that's not too bad, that's just 2x. G prime, I'm going to have to use the chain rule. To figure out g prime, I want to take the derivative of this. The derivative of this is e to the 2x plus 1 times the derivative of 2x plus 1. Where's that coming from? The derivative of e to the x is just e to the x, so that's where this part comes from. But I don't have e to the x, I have e to the 2x plus 1, so I have to multiply by the derivative of 2x plus 1. The derivative of 2x plus 1 is just 2, so what I get for g prime is 2 times e to the 2x plus 1. So now that I know that, I can say my product rule tells me that the derivative of this thing, f prime g plus g prime f, is equal to 2x f prime times g e to the 2x plus 1 plus g prime, which is 2e to the 2x plus 1 times f, x squared. F prime g times g prime f. So what I have for my final answer is this times this derivative, but this derivative I just figured out down here. So my final answer is 3 times x squared e to the 2x plus 1 squared times, I'm going to put parentheses in because I got two terms, 2x e to the 2x plus 1 plus 2x squared e to the 2x plus 1. What I did is I recopied this down here, but force of habit, I like having my x's before my e to the x's, so I wrote the x squared first. I don't care what order you write this stuff in. If you get something like this, it's pretty impressive, because it's pretty hard to do the product rule inside the chain rule. And I guess in this case, we actually did the chain rule inside the product rule inside the chain rule. That's this answer. Next one, h of x equals this mess. My little hint on these when you have trig functions raised up to powers is to rewrite them. Think about this as sine of e to the sine of x squared. I think it helps to have this 2 out on, this means the same thing, but I think this is easier to look at. Because this we can take the derivative of. We can say h prime is equal to, if you had to take the derivative of this, the outermost function is x squared. It's something squared. So using the power rule, I take that 2 down in front and leave all this mess alone. Now I have this raised up to the 1 power. You don't have to write to the 1 power. But then I'm not done. I still have to multiply that by the derivative of all this inside stuff. All this stuff I haven't taken the derivative yet. Sine of e to the sine of x. Well, the derivative of sine of e to the sine of x is another chain rule. The outside function sine of x, this sine of x. The derivative of sine of something is cosine of that something. But then you're not done. You still have to multiply that by the derivative of that something, e to the sine of x. How do you figure out the derivative? So this entire thing is this derivative here. But this isn't done. I still have to figure out this part. I don't know if those arrows are helping. I'm going to leave those off. Still have to figure out this derivative here. Can do that. The derivative of e to the sine of x, the outside function is e to the x. The derivative of e to the x is just e to the x. So I get e to the sine of x. But then I'm not done. I have to multiply that by the derivative of sine of x. Derivative of sine of x is just cosine of x. So what I finally get is that h prime of x equals 2 sine of e to the sine of x times cosine of e to the sine of x times e to the sine of x times cosine of x. Chain rule inside chain rule inside chain rule. Maybe more, I don't know, I lost track. Get this for the derivative here. All right, one more of those. The 2's problem. So for the 2's problem, we want to take the derivative of this mess. J prime of x is equal to the derivative of 2 plus 2 raised up to the 2x squared plus 2x plus 2 squared plus a bunch of 2's. I don't know how many there are. Whatever. Good enough. 0.2. Bunch of 2's. Derivative of this mess. A couple things to notice. When you're taking the derivative of a sum, all you have to do is take the sum of the derivatives. What I'm saying is I need to figure out the derivative of 2 plus 2 to the 2x squared plus 2x plus 2 squared. And then to that, I need to add the derivative of all my 2's. Oh, that looks stupid. Bunch of 2's, however many there are, 0.2. Why do I not care how many there are? Because this is just a constant, it's just a number, so the derivative is 0. This is just plus 0 right here. This is the derivative that I need to figure out. Well, for this derivative, I have to use the chain rule. The outermost function is something squared. So I bring that 2 down in front, and I multiply that by everything inside these parentheses. 2 plus 2 to the 2x squared plus 2x plus 2 Now it's to the 1 power instead of to the 2nd power. But then I'm not done. I have to multiply that times the derivative of everything left inside the parentheses. 2 plus 2 to the 2x squared plus 2x plus 2. And then this plus 0 is from the derivative of a constant. So I'm making some progress here. Got all this stuff done. I still have to take the derivative of all this stuff. The derivative of all this stuff, well, the derivative of a sum is the sum of the derivatives. Derivative of 2 is just 0, so this just goes away. So I need the derivative of what's left over here. The derivative of 2 raised up to the x power is 2 to the x natural log of 2. So when I'm taking the derivative with this as the inside function, instead of writing 2 to the x natural log of 2, I'm going to write 2 to the something times the natural log of 2. But then I'm not done. I still have to multiply that by the derivative of that something. In this case, 2x squared plus 2x plus 2. So what I get is this is all the same. I just have to figure out the derivative of this thing. Finally, something that's doable. The derivative of a polynomial, just take it term by term. The derivative of 2x squared is 4x. The derivative of 2x is just 2. The derivative of 2 is 0. So what I get for my final answer is 2 times 2 plus 2 raised up to the 2x squared plus 2x plus 2 times 2 to the 2x squared plus 2x plus 2 times the natural log of 2 times 4x plus 2. And I got this one I copied, this one I copied, and this one I copied. This entire mess right here is our final answer. This is what happens when math teachers think they're funny. They give you a ridiculous problem like this. That's the final answer. That's the end of this quiz.